for series parallel capacitance, the rules of conductance works on this. That as we know that in resistance, when we have a series resistance, we add it, and when we have a parallel resistance, we will use like 1 over R1 plus 1 over R2 plus equal to 1 over R equivalent. So this is the rules of conductance apply on the capacitors. This means that, so conductance, like we have G2 plus G1 equal to GEQ. So this is the, when we have the parallel capacitance, we add it, and when we have a series capacitance, we do the same as parallel resistance, 1 upon C1 plus 1 upon C2. So this is the series parallel capacitance. Let's solve one example. So if you want to calculate C, this is, what is this, series or parallel? Yes, right, this is right. This is series, because this one end is not, both end is not connected with this, with both end of this one, but one end is connected with one end, there is no branch as well. So this is series. So in series, that is the formula, we have to multiply. We have to multiply with both of them, divide by the sum of these two. So we have to multiply both of them, divide by the sum of the 20 and 5. So this is the one capacitance. So what is the way to do it? I'll just make a diagram again, so it make it easy for you to understand. This is the capacitor, this is the capacitor, because this is the, I make it the equivalent of 20 and 5, which is 4 micro. So we have 3 parallel capacitor, 6 micro, and this is 20 micro. So this is the 3 capacitance. So the equivalent of these 3 capacitance becomes 1 capacitance, which is 30 micro, and then 30 micro is series with 60 micro. When we have a 60 microfarad, so we can say that 30 multiplied by 60 divided by 30 plus 60, so it becomes 20 microfarad. CEQ is 20 microfarad. So I hope you understand this part. The next part we have that we want to calculate the voltage across the capacitor. The first we have to understand that the rule of the flow of the current, the charge is same as the flow of the current. So similarly, for what we have to do first, we calculate the capacitance, total capacitance. So how to calculate? This is a parallel, as we know that this end and this end is connected with both ends, is parallel. So when we have a parallel capacitance, we just add it, 20 plus 40 60, and when we have 60, they all becomes series. This is the equivalent, the equivalent of these two comes here. So okay, so the equivalent of these two comes here. So this all becomes 3. So 20, 30 and 60. So you can have the 1 upon 60, 1 upon 30, 1 upon 20. So to calculate this one, we can have 1 over CEQ is equals to 1 over C1 plus 1 over C2 plus 1 over C3, and so we can have if we take a reciprocal, so it becomes, both are reciprocal. So this is 1, this is a 10 millifarad. If we calculate this one, we take LCM. So we take LCM of 20 plus 1 over 30 plus 1 over 60. The LCM is 60. So this becomes 3, this becomes 2, this becomes 1. So 1 over CEQ is equals to 1 over 10. So we can say that 1 over CEQ is equal to 1 over 10. So we can say that CEQ is equals to 10 millifarad. So when we have a capacitance, we can calculate the Q, total Q. We have Q is equals to CV, and we already know CEQ, we already know the V. So we have the total charge Q. So we already tell you that the flow charge is similar like a current. So we follow the current. In series, the current is same, so the charge is same for all. So the current discharge 0.3 multiplied by if we want to calculate the voltage across this capacitance, so we have Q is equals to CV. So we have to divide by the capacitance. So V1 is equals to Q divided by C1, V2 is equals to Q divided by C2. And if you want to calculate V3, so we already have Q divided by C3. So the C3 means that the equivalent of 40 and 20. So 60 was there. So we have the 5 volts. When we have a 5, we already have calculated V1, we already calculated V2, we already calculated V3. So it becomes V1 is equals to 15 volts, V2 is equals to 10 volts, and V3 is equals to 5 volts.